In the evolving world of renewable energy, the wind turbine has stood as a proud testament to humanity's ability to harness nature's power. For decades, towering wind turbines have dotted landscapes, converting the raw power of the wind into clean energy. Among these giants, the Liam F1 wind turbine has emerged as a captivating example of design and functionality, showcasing how, even in a saturated market, innovation can redefine expectations. When discussing the Liam F1, one must first acknowledge its striking design. Unlike the traditional horizontal axis wind turbines that most people picture, those with long blades rotating around a horizontal axis, Liam F1 belongs to the vertical axis wind turbine family. The most evident distinction of the Liam F1 is its nautilus shell-like structure, a spiral design that's not only aesthetically pleasing but functionally remarkable. This intricate design ensures that the turbine can capture wind from any direction, removing the need for the turbine to rotate and face the wind. The creators of Liam F1, the Dutch company the Archimedes, were deeply inspired by nature and mathematics. Their core design premise lies in the logarithmic spiral, mimicking the natural spirals seen in seashells and galaxies. By applying this concept, the turbine claims to achieve energy yields that are 80% of the maximum that's theoretically possible, termed as the Betz limit. This is an astounding figure given that most commercial wind turbines achieve around 35–45% efficiency. But how does Liam F1 stack up against its competitors? Globally, companies like Vestas, Siemens, and General Electric dominate the wind energy market with their HAWT designs. These turbines, often surpassing 100 meters in height, are engineered for large-scale energy production. Their massive blades and towering height enable them to capture stronger, more consistent winds at elevated altitudes. Models like the Vestas V164, which boasts an impressive 9.5 MW capacity, are monumental achievements in wind technology. Yet, Liam F1 wasn't designed to compete with these giants on their turf. Instead, it offers an alternative solution. At a modest height of 1.5 meters and a diameter of about 5 meters, it's intended for urban environments and individual households. Its small size and unique design mean reduced noise, a frequent complaint with larger turbines, and the ability to function efficiently in turbulent winds commonly found in cities. Another player in the VAWT market, which might be considered alongside the Liam F1, is the Savonius turbine. With its simple S-shaped design, it operates silently and is primarily used for low-power applications. However, where the Liam F1 shines is its blend of simplicity and high efficiency, combining the best of both the VAWT and HAWT worlds. That said, no turbine is without its criticisms. Some experts have raised questions regarding Liam F1's durability and efficiency claims. They argue that its design, while innovative, may not withstand long-term wear and tear, especially in turbulent urban environments. Additionally, achieving close to the Betz limit in real-world conditions might be more challenging than in controlled tests. Yet even with these concerns, Liam F1 stands out as a testament to the importance of innovation in renewable energy. In a world where we often think bigger is better, the Liam F1 challenges this notion by introducing a design suited for smaller scales and individual needs. It brings forth the argument that renewable energy solutions should not only be grand but also accessible. Manufacturers like the Archimedes, Vestas, and Siemens represent the diverse approaches to wind energy technology. From gigantic turbines designed for maximum output to smaller, aesthetically pleasing models meant for urban rooftops, the wind energy landscape is rich with potential. Each model, each design, carries with it the promise of a cleaner, more sustainable future. As our planet confronts the urgent challenges posed by climate change, the search for renewable energy sources has become paramount. Wind energy, a tried and tested avenue for green power, continues to see new innovations. Among these, the Liam F1 has not only diversified the design portfolio of wind turbines, but has also demonstrated that small-scale renewable energy solutions can be both efficient and visually compelling. The importance of diversifying our approach to wind energy cannot be stressed enough. Large commercial turbines, while potent and efficient, are not universally suitable. Their immense size requires significant open spaces and vast investments. Moreover, the infrastructural challenges associated with transmitting the power generated in remote wind farms to urban centers can be daunting. In this context, the role of turbines like Liam F1 becomes crucial. By decentralizing energy production and bringing it closer to consumption points, such turbines address the energy transmission challenge and offer a more democratic approach to power generation. Furthermore, the aesthetic design of the Liam F1 and its compact nature make it an attractive option for urban planners and architects. The integration of renewable energy solutions into urban infrastructure and architectural designs is a burgeoning field. The Nautilus-inspired Liam F1 provides an example of how these turbines can become part of the urban aesthetic rather than standing out as unsightly appendages. But the Archimedes isn't alone in recognizing the potential of small-scale turbines. Companies such as Turbine have introduced unique designs meant for placement in small rivers and streams. These hydro turbines, much like the Liam F1, emphasize localized energy production, with the potential to power individual homes or small communities. Such decentralized solutions echo a rising trend in the renewable energy sector, the move towards personal and community-driven energy production. However, the future of wind energy isn't just about diversifying designs, but also about improving integration with other renewable sources. The interplay between wind turbines and solar panels, for example, can be optimized to ensure consistent energy production. On days when the wind might be still, sunlight could fill in the gaps, and vice versa. Such hybrid systems comprising of devices like the Liam F1 paired with solar installations might just be the way forward for residential renewable energy solutions. It's also worth noting the societal implications of turbines like Liam F1. By making wind energy more accessible and personal, it empowers individuals to contribute directly to the fight against climate change. This personal investment can drive more substantial societal shifts, fostering greater acceptance and enthusiasm for renewable technologies. When individuals can see, touch, and understand their personal energy production, it demystifies the concept of renewables and brings the green revolution to their doorsteps. The potential impact of small-scale wind turbines, as exemplified by the Liam F1, goes far beyond individual homes or urban landscapes. The global implications of widespread adoption of these technologies can reshape our understanding of renewable energy distribution, particularly in regions that lack the infrastructure for large-scale energy projects. Consider developing nations, where many communities remain off the grid, untouched by the advances of massive wind farms or expansive solar fields. For such regions, the cost and logistical challenges of establishing extensive power networks are staggering. Here, decentralized energy solutions can offer a beacon of hope. Turbines like Liam F1, with their compact design and relatively simple installation requirements, can be the pioneers of green energy in remote villages and towns. By introducing localized wind energy solutions to these areas, not only can we provide them with a reliable power source, but also empower them with sustainable livelihoods. Maintenance, management, and further development of these renewable sources can lead to job creation and skill development in communities that previously lacked such opportunities. This localized approach also has the potential to preserve local ecosystems. Instead of large-scale land alterations that come with massive energy projects, smaller turbines can be integrated with minimal disturbance to the environment. The result is a harmonious blend of modern technology and nature, ensuring sustainability not just in energy production but also in ecological preservation. The global energy narrative has, for a long time, been dominated by a few key players who manage vast grids and sprawling energy farms. However, as we inch closer to a future defined by renewables, it's clear that this narrative is changing. Distributed energy resources, represented by innovations like the Liam F1, decentralize this power both literally and figuratively. In conclusion, the Liam F1 wind turbine is more than just a piece of renewable energy equipment. It's a symbol of the innovative spirit, a reminder that sometimes looking to nature and revisiting age-old mathematical principles can pave the way for groundbreaking designs. In the broader tapestry of wind energy, from the immense structures developed by companies like General Electric to the compact designs of the Archimedes, each innovation pushes us one step closer to a sustainable future. It's a journey of harnessing the wind, one gust, one rotation, and one innovation at a time. Thank you for sticking with me until the end. Please like, comment, and subscribe, and be sure you turn on the notification bell so you don't miss a video. Take care until the next time.